So I'm going to show you two ways how to do 6. Kind of like I want to say we did 3, and I showed you 2 different ways.
3 and 9, we did those.
So I showed you how to deal with the fraction and solve it, and then get rid of the fraction. We're kind of going to do the same thing with 6. Methods are going to be similar, but different because we already have fractions. So in this first way, we're going to deal with the fractions, leave them, and then go from there. If you like that method, you can use that. If you rather use that one. So for this, if we have these fractions, right now they are being added together. You can't actually add them together because they don't have the same denominator, the number of bottom. So to actually be able to add them, we have to make this number the same. So we have to think about some number that these two both go into multiplying wise. What number comes to mind? 6. So if I were to make these both 6, I would need to multiply this by 2 and this by 3. But with fractions, what you do to one piece of it, you have to do to the other piece of it. So if I do this to the denominator, I can do this to the numerator. And same thing here. That's kind of like so then it's going to change. This will become 4x over 6 plus 3x over 6. Now we have the same denominator, so I can combine these two fractions into one big fraction. Let me know if I'm going too fast. And now we have those like terms, the 4x and the 3x, that we can combine to get 7x. So this has become a little bit easier. From here, we can do a couple things. We could start solving this like a normal fraction, get rid of the 6 and then divide by 7. Or if we look at this a different way, we could do both of those steps in the same step. But we have to, instead of seeing the x just in the numerator, we have to kind of rearrange this a little bit and say that this is the same thing as 7 over 6 times x. These are the same thing. Last class we talked about how when you're multiplying fractions and whole numbers together, the whole numbers are really fractions. They always have a 1 underneath it. This is invisible. Same thing can be said about all of your variables. There's like an invisible 1 under here. So if I were to multiply across, we get this exact same thing. So that's why this works. And I want to say it was in this class we talked about multiplying by the reciprocal. So we're going to do that same thing here. Take this fraction, flip it, and we're going to multiply that on both sides. So you could put that in your calculator. So speaking of, if you do not grab your calculator, you can go grab it. If you know what your calculator number is again, I can tell you what that is.
Then,
To put fractions back in our calculator, I'm going to set this up 7 times, and then to get our fractions, we're going to go back to alpha y equals. Use that first one, the n over d, and then we can put in 6 over 7.
so it's the first option?
Yes, the first option, the n over d. So when you get there, you can hit 1 or you can hit enter, either or. What did we get for that answer? questions on that, how we got that answer, that method, before I show you the second one? If you like that first method and it makes sense to you, you don't have to write this back down. If you want to still write the second method down so you have a different way to do it, or you want to do that. So we wanted to get rid of the fractions. I see this problem, it's not making sense to me, and I just want those fractions gone. We're kind of going to do the same thing. We need to multiply both of these by something that would get rid of both of our denominators. So we would need something that is a multiple of both of them, or something I can multiply these both by. So 6 would again work here. So I'm going to take this entire thing and multiply this by 6. And then what I do to one side, I have to do to the other because of our properties of equality. When we multiply this 6, I'm going to treat this like kind of like I'm distributing because this is really 6 over 1. So if I was multiplying this to both of these things, this would be 6 times 2x and 1 times 3, and 6 times x and 1 times 2. So I'm not multiplying to the denominators, just our numerators. So we have 12x over 3, and 6x over 2, and 42. So we still have the fractions for a moment, but they're about to go away. We can simplify both of these. 12 divided by 3 would give us 4x, and 6 divided by 2 would give us 3x. So now all of our fractions are gone. And we can just work this problem out. Combine your like terms and solve for x by dividing. We still get the same answer, just a different one. Who liked the first method better? A couple of us. And who liked the second method better? A lot of us. Do you have questions on either? Anyone still writing this down? We go back. So we added 4 to our question, so we'll do 4 and then 10. You may have 10. So with number 4, we're going to get a by itself. So we're going to get rid of the 6 and the 3. What would we do first? But is it just like the 3 or are we following simple? We do the inverse, so what? What would you do to the negative 3? Add it. Add it. I'm going to get both sides. When we divide this, that would be our next step, we're going to end up with the fractions, and then that happens. If you do end up with a fraction, simplify it. Always. If it's a nice enough fraction that if you put it in your calculator, you get a decimal, the decimal stops, and you see it stop, you can write that as a decimal. Here, what would this be when we simplify this? Let me use your calculator to see what it looks like. So using that same alpha by equals, you can put in 15 over 6, and it'll simplify it for you. That would be the decimal. What would be the decimal, guess? What would the fraction be? or sorry, what did you say? Four doesn't go into 15, so only 4, but you're close. If you were to divide these both by 3, you would get 5. So, I'm sorry. What was that going to say? So here, if you want to put 2.5 or 5 halves to the door. But if you got 5/3, and that's a repeating decimal, let's just leave that as a fraction. Questions on that one? Number 10. This is one big division problem. You need to get rid of the 12, the negative 12, and the 9, but we can't do anything with our numerator until our denominator is gone. So how would we get rid of this 9? We're already dividing, so we have to do the opposite and multiply. So when we do this, I'm going to kind of put this in parentheses. And I'm going to think about this kind of like how we rearranged the 7, 6. Instead of thinking about this like I'm multiplying 9, don't write this down. Instead of thinking about this like I'm multiplying 9 to my numerator, I'm going to think about this like I have this fraction, 9/9, and I'm multiplying that to my minus 12. Because then my 9/9 simplifies, and I don't have to distribute and then simplify. So because this would simplify, I can say this would go away, that would become 1, and I would be just left with k minus 12 to write this part. Equals negative. Oh yeah, I did that. Yes, I did that. 18, that's mine. My brain is not working.
Guys, why is it negative 18 not possible? Yes, exactly. We need negative and negative to make it possible. But we want a negative 2 in that situation, so we keep a negative.
Okay. This one, now we just gotta get rid of the 12. By doing what? So our k value equals negative 18 plus 12. Does it make sense? Yeah. We did not do this for the last couple, but I'm going to go back and do this for this one. We put this back in here. Negative 6 minus 12 would give us that negative 18. Negative 18/9 would give us negative 2. So that is a true statement. That works. Do we have any other questions on this that we wanted to go over before I practice? You guys said we did number 9. I want you to try number 8. If you already tried that, great. If you want to try others, go for it. But at least try number 8. What is number 8? Answer did we get for number 8? Where did number 9? Anyone wants to share?
Everyone's afraid of being wrong, but it's okay if you didn't get the right answer.
And remember, our expectations, it doesn't hurt to try. So we're having you try something and not say nothing at all. Okay, so we
Gonna do a little over here. Who else got negative?
Design.
Yeah, or I agree. So a few of us, anyone that got a negative 11 want to show how they got it on the board or walk me through it.
I can like get up.
Okay, so tell me how you think this works.
So here's what I did.
Okay.
I did what did I even do? I did -3 times 2 and times the -7.
Okay. So we distribute it, right?
Yeah, I did my paper even how. And then I brought everything down, so I put 1y minus 6y plus 21 equals 76.
Okay.
Then I subtracted 21 from 76, which gave me 55. I just divided. Whoa, wait, I'm tripping. I did the -6y minus that y, which is 1.
You combine your like terms.
Yeah.
There you go. And got what?
I did 1y and I subtracted 6y from 1y, and then I divided. That gave me -5. Then I divided that -5 to the 55, which gave me -11. Yeah.
-11 was our answer. So if you did not get that, you may have forgotten to bring down the y. You may have, instead of just combining these, so as a couple times, try to do it like you were adding or subtracting the inverse. And remember, we only do that if they're on opposite sides. You may have not brought down, this should have been a positive 21. If you brought down the negative, that would change your answer.
Yeah.
So all of those things. Any questions on that one? So we are going to move on to, I passed out the next, it's like part 2 of the same notes, where now we are solving equations that have variables on both sides instead of just one. Which is what we were doing before. Alright, I sometimes use this, like, this is a good, helpful tool. If you're not sure what to do first, you could follow this. Sometimes you don't need all of these steps, just like, before we sometimes don't have to distribute or combine the terms, it just depends. So, don't call me after midnight is really for these steps. Distribute. Combine like terms.
That's supposed to be okay.
And then move a constant or variable to the other side. And the way we do that is to add or subtract. We usually have to repeat this step, move the other constant or variable, and add or subtract. And then we end up with a variable term equals a constant term, and to get that variable term completely by itself, we multiply or divide. So similar steps to just solving in general, but we may need to move things more than once. Right, so if you need a way to remember this, don't call me after midnight, distribute, combine the terms, move, add or subtract, and then. So we're gonna use these to solve this. It's kind of like a, I forgot the word in English where you like foresee something, foreshadow. There we go. So we're gonna do this, and then we're gonna kind of backpedal, do some more easier ones, and then move into this. So our first step that don't distribute We're going to do that on both sides at the same time. So we would end up with 8x plus 4. I'm going to bring everything else down. Minus 2x equals 8 plus 4x plus 20. There's a lot of terms in there. Make sure you're making sure all of the negatives and positives are correct. All of your numbers are correct. Then our combining like terms step is on the same side. So I know we have x's and constants on both sides. We just focus on one at a time. So on this left side, I'm just looking for like terms on this side, which would be my 8x and my negative 2x. So I could combine those to get 6x. On the right side, our like terms are just our constants, 8 and 28. So that would give us 28 plus 4x. Questions so far? Then our goal is still to get all the variables on the same side, get the variable by itself. But in order to do that, we have to move our variables to the other side and move our constants to the opposite side. So it does not matter which one you choose to do first. You have 4 different options. Everyone in this room may choose a different term to start with, and that's okay. So someone tell me something they want to start with. Pick one of these 4 terms. Aaron? The 4x or just the 4. Okay, so let's reciprocal the plus 4. So if we start with this, we would need to move it to the other side by adding or subtracting. Which one are we going to use here? Adding or subtracting? Subtracting, because we have to use our inverse. So we're going to subtract that to the other side. But when we do that, they have to match up. Like, we can't put a 4 that doesn't have an x with something that does have an x and vice versa. So constants with constants, variable terms with variable terms. All right. Right, so if we did that, we'd end up with 6x equals 24 plus 4x. Can we do anything else? So now we've moved a constant to one term, but we still have variables on both sides. Now I need to get both of those variables on the same side. So whatever direction we move the constant, we're going to move the variable in the opposite direction. So then move this variable to the left and do the opposite. So subtract. So the M and the A here, the first M and then the A, we kind of do that twice. We move a constant or variable by adding or subtracting, and then do it again, either constant or variable, the opposite of whatever we did before. And then we can do that last step, multiply or divide. In this case, we are doing which one?
Or which one you're dividing?
Yes. So our answer would be what? With these, you would go back in and put 12 in for every single x you see to double check and see, does this work? I will say 12 is the correct answer for this one. Before we continue, do you have any questions on that? So if you ever get a problem and you're not sure where to start, think, don't call me after midnight. Can I distribute? Can I combine the terms? If not, can I move a constant or variable to the other side and then move the other constant or variable to the other side? Add or subtract and then divide. On the next page. This is like a continuation of the first part. We did this when we were just solving and we had variables on one side, but now that we have variables on both, we want to see, can we look at this and see what is happening to both sides. So we're going to do a couple of these together and then I'll let you try some. We are still using our same properties as before, our different properties of equality, addition, subtraction, multiplication, division, which tells us we have to do them to both sides, as well as distribution property. Okay. So this first one is given, and we're looking at what changed, or what did they do from here to here, from step 1 to step 2. What did they do?
10k minus 4 equals 2k minus 20. And it turned into 8k minus 4 equals negative 20. So what changed?
They subtracted 2k on both sides, so that would be your subtraction property of equality. Once you get past that first step, everything else is similar to what we were already doing. From step 2 to step 3, what did they do? Right.
They added.
They added 4 to both sides. So your addition property of equality. And then our last step, from step 3 to step 4. They divide by base. So our division property of equality. I think after we get everything separated, or it becomes more like we just have variables on one side, it becomes easier. But trying to figure out, okay, what did they do to get there? For right now, I think is the most complicated part of this. I see some of us still writing, so I'll give this a second.
So when you see a chart like this and asking for the property of equality, you want to just describe what the step was done. So it's kind of like as if you're tutoring somebody and showing them what the steps are.
And it kind of helps you if you could see what was done. Then when you go to solve it on your own, you kind of recognize, oh, I should be doing this and then this and then this. Anyone still writing this down? Okay, we're going to jump down to example number 7. The last one on the page. So that one has a lot more, but we're just going to, again, take it step by step and see what changed, what did they do, and go from there. So we have this big long equation. What did they do from step 1 to step 2? So I mean, distribution. Yeah. But yes, you were also right. They multiplied the negative 2 here, and there's a negative 1 that they multiplied here. They just didn't use the multiplication property of equality. They didn't do that to both sides. They did distribute. Okay. From step 2 to step 3, what did they do there?
You guys notice that it's gotten shorter now, right? So how'd they get that? You guys I see more numbers or less numbers on number 3. Step 3.
Combine like that.
They combine like terms, correct?
Paradise, are you going to do the next one? If you want.
So when you're thinking of your properties of equality, you're doing the exact same thing to both sides. So we would need to subtract 16 to this side and this side. So if we're just subtract, they both happen to be subtracted, but not the exact same thing. It wouldn't be your property of equality, just that they combine like this.
Usually when we think of product of equality, it's always equal to both sides. So like both sides get the same treatment.
Yeah.
Like a balance beam.
Almost, yeah. Right, and then from step 3 to step 4.
Subtraction.
What did we subtract?
She subtracted 2x and negative 2x.
This 2x over here. Yes. Because what's attached to that 4x? What's symbol? Negative, right? So it's kind of like you give a factor that something must have been subtracted to it to go lower the value. I did not do this, so I'm going to go back really fast to circle or square are like terms that we combine. Right. Now we have all of our variables on one side, so this looks more like what we were doing before. What did we do from step 4 to step 5? Addition, and what did we add? To both sides. And our very last step from step 5 to step 6. Division. And that's usually our last step. Sometimes it's multiplication, but it's usually division is our last step. Okay. Do we have any questions on that part? Yes. Okay. One more second. Let me make sure I don't have any other questions on 7. Right. I do want you guys to try number 5 and 6, but I am going to give you this last one. Because they're just switching the order in which you write the answer. That doesn't really matter, but that's your symmetric property, and that's not listed here. So that's just saying how you write the answer does not matter. I could write it as -6 equals n or n equals -6. It doesn't matter. Back up. Right, so I'm going to give you guys a couple minutes, try 5 and 6, and then we'll come back and we'll talk about those. Look over 5 and 6. We have anything that we disagreed with. Maybe we got something different. Anything we had questions on. I think for the most part, I saw the same answers for 5, for 6. The only thing I saw that may have been different, you may have been thinking subtraction property of equality. 1, because there's a lot of negatives. And as we're moving things, we have to do the opposite or think about what we need to do to get rid of it. So from step 2 to step 3, we are moving the 5w, the negative 5w over by doing the opposite, adding it to the other side. But even though we added it, it wasn't a big enough number to get a positive, so we ended up with a negative. That may have caused confusion and you may have thought subtraction. And then the same thing happened here. We added the -8 to both sides, or added 8 to both sides to undo the negative. But the number wasn't big enough to make this a positive, so we ended up with another negative.
So that can be confusing when trying to keep all of that stuff. I lost the word I was trying to use. Straight. There we go. Keep all that stuff straight.
And it doesn't hurt to double check with your graphing calculator too. So if you're wanting to double check and make sure that negative is put in the right place, then double check and make sure it doesn't either turn into a positive or a negative intentionally.
Any questions about this page? On the next page, look through those and tell me which ones you want to see up here on the board that we go over together. It may look hard, confusing, you don't know where to start with that. You just want to, maybe you already tried it and you want to see if you're on the right track. Any of those. Which of these do we want to go over? 7. Some of these are similar, so if we get a lot of the same, we probably won't do all of the same type, because I want you to be able to try them too. Aaron? 6. So
9.
6 and 7 and 4 are all similar, so we're not going to do 4, but we can do 9. Any others?
I want to go with number 5 because that fraction distributive is going to be intimidating.
Alright, so we're going to start with 5, go to 6, go to 7, and then 9. Okay, so with number 6, we have something we can distribute on both sides. So we're going to start there. On this side, the left side, it would be just like normal. On the right, we're still going to distribute this fraction. But I'm going to give you a way to think about it instead of multiplying a fraction to both of these things. So working this part out, we have 30m, and 6 times negative 3 will be negative 18. Instead of thinking 1/3 times 24, and this really only works if the numerator here is 1, you can do what I'm about to say. If it's not, then you have to do 2 steps, but we'll get there in a second. Instead of multiplying 1/3 and 24, I can think about this as 24 divided by 3. If I were multiplying them across, I'd end up with something like this. All whole numbers are really fractions themselves with a number of 1 in the denominator. So if I multiply it across, I end up dividing anyway. So instead of going through all of that motion, or you could put it in your calculator, either one, we can think about this as 24 divided by 3 and 12 divided by 3. And that may help you look at it a little bit, or make it a little bit easier. So 24 divided by 3 would give us 8m, and 12 divided by 3 would give us 4. Sometimes you would keep, depending on the answer, sometimes there would still be a fraction, sometimes it would go away like it just did. It just depends on the problem. Then we could continue. So don't call me after midnight, we distributed. We don't have like terms on the same side that we can combine, so we can skip that step and move on to the next one. There are now 4 terms that we can pick and choose and move. Which one do we want to move first? It does not matter. Which one calls to you? You're like, I want that one first. -18. Okay. So if we are moving -18 to the other side, we're doing what? To undo it. Adding it. Yep. We're going to add that to the 4. So we have 30m equals, these two would cancel. 8m plus 22. And then we would need to go back and move this 8m back to the left. So opposite is already positive, we would need to subtract.
So we end up with 22. So now we have a variable on one side, a constant on the other, and we can solve this by dividing. What would our n equal?
1.
1. If I were to put that back in, since it's a low number, I could do this in my head. 5 times 1 is 5. 5 minus 3 is 2. 6 times 2 is 12. And then 24 times 1 is 24. 24 plus 12 is 36. And 36 divided by 3 is 12. So those equal each other. That is a true statement. Do we have any questions on 5? Number 6. This is a proportion where you have a fraction that equals another fraction. Anytime you have a fraction that equals another fraction, there's a specific way to start it. Does anyone know how to start solving proportions? Erin? It's okay.
What would you do?
Yeah, so I'm going to say the step and how you got that, but yes, that is actually correct. So you are going to cross multiply, taking this numerator, multiplying into everything here, and this denominator, and multiplying into everything here. So not multiplying across, but like diagonal. And when we do that, we're going to rewrite it. Does not matter if I put this, the 8 and the n plus 8 on the left, on the right, that part does not matter. But I'm going to put whatever has a multiple in parentheses. And again, if you switch those to the 7 and then in parentheses n plus 10 is on the left, that's okay. But now this looks a little less challenging as it did in the ratios. Because now it's just going to be another problem like 5, where we distribute both and we kind of go from there. So we would get 8n plus 64 equals 7n plus 70. I am going to start doing the 2 steps we did here, moving 18 and moving 8m. I'm going to start doing that at the same time. If you would like to still see it written out as 2 separate steps, you can still do that. I'm just going to do it as one combined step. So what I mean by that is, let's say I wanted to move 7n over here to the left. And I know that later I would have to, these would cancel. And then I would have to move that 64 over to the left, over to the right, sorry. I'm going to do this at the same time instead of separating it. You can still separate it and that's fine, but if it helps you or you want to do them both in the same step, you could also do that.
I'm just going to put the acronym on the board too, because you can use this as a checklist.
Okay, so as we're going through this, 8n minus 7n would give us just n. Plus 64 minus 64, those would cancel. My 7n's already canceled. And 70 minus 64 would give us 6. So it's kind of knocking out some space. Instead of writing 2 separate steps, you're just doing the same thing, but just all together.
That definitely helps save space on the paper.
In this case, we didn't have to multiply or divide because we only ended up with 1n. We could have divided both sides by 1, but you get the same thing, which is 6. Do you have any questions on 6?
7 is very similar. We have another thing, or another equation with fractions, or we have ratios or proportions. How would we start this?
Do across the equal sign or do we crisscross it?
Crisscross it. We're going to multiply 3nb minus 3, and then 8nb minus 4. And then our first step would be to do what?
Don't call me after midnight.
What's the first one? Sid, are you going to answer that? No. What would we do first here?
We got sticky heads in here. Thank goodness. What's the first one, guys?
Distribute. 3b minus 9 equals 8b minus 32.
Yes! I heard that.
Like the pen hit my elbow really hard. Oh my gosh, that hurt.
Alright, do we need to combine any like terms right now? On the other side of the equal sign? No, so we don't have to do that step. Okay, what's our next one? What's the M? Move, yep, move constants or variables, so we do have to look on those. So
And I'm going to do them both again at the same time. So I'm going to move my 3b over here. And again, you could do it the opposite way. The order does not matter here.
as long as one constant and the variable's on other sides of the equal sign.
So that would cancel out my 3b's, and I would need to move my 32 over here by adding. So we'd end up with, what's negative 9 plus 32? 23. And 8 minus 3 gives us 5.
And the last step of our acronym is division. Multiply by 5, we're going to divide. And we got through the acronym.
So 23 over 5 or 0.6, I think. Or 0.6? So either or, you don't have to write both. Questions on that one?
Because I know the process tends to get like unconscious feeling now because I mean you guys did go through the same process since I don't know algebra 1 or pre-algebra, but it doesn't hurt if you want to put the acronym on the desk or something or on the side of the equation, so that way you make sure you have each step done as needed.
9 is similar, it just has a lot of stuff already on this side, plus still stuff on this side. So for this, we would still do that first step, still distribute. So 8y plus 32 minus 2y. Be careful here with your negatives. We have a negative times a negative, so 8 positive, 2 not 1. And then bring everything else down.
Can we combine like terms on either side of that equal sign? I say so. What can we combine there?
-8y, negative 2y, to get 6y. Any other like terms? Is 2 and 32, yes. To get 34.
Do we have to move any variables or constants to either side of the equal signs?
I would say, unless they're already both over here, so I had both
y's over here or both constants over here, that answer is always gonna be yes. I'm gonna say, let's move the 3y over here. I like to keep our terms positive if at all possible.
Less stress.
And then subtract 34. Have 9y, because these would cancel, equals 70 minus 34 would give us 36.
Okay, do we need to multiply or divide anything to leave y by itself? Yep, what number do we need to divide, guys? 9. Good, so we have this last step.
And y equals what? 4. Okay. I'm going to show you one thing on Desmos, and then we'll leave the next page for next class, and we'll also talk about literal equations. I do want you to try problems 4 and 8 on this page, if you haven't already. 4 and 8, try those. Before you try those, look up here really fast. I thought I had this written up here. I did not. So I'm going to put in our equation for 9, but instead of y's, I'm going to put in x's. So this is on your Desmos graphing calculator that you can, if you have it on your phones, you can access that. If not, it's on Canvas on a side link. Desmos does not like y as a variable, so we're going to use x instead. X plus 4 minus 2. Minus 1 equals 7 minus 3x. So when you put in an equation like this, and I'm zooming out a lot, it's going to graph some line. That line is going to be on some x value, and that x value will be your answer. I'm telling you this so you can use this as a way to check yourself. Because if you put this in and this answer is not the answer you got, something's wrong. We need to go back and fix it. So even though you can use this to check yourself, you'll still need to be able to actually do the work. So keep it in mind.